Hi there, welcome to my Node.js backend project. What we're going to be doing is we're going to be implementing this pet store API listed here on Swagger and showing the functionality. So let's get right into it with Postman. So we have our API gateway link here, and this sends it to a Node.js Lambda function and connects it to DynamoDB as the backend. So we have our pet ID is 3241, pet name is Tony, and our status is available. So we're going to send this and we are going to see pet was created. Okay, let's go through and see what's happening. First things first, this is the Lambda function. We're going to go to Lambda function, hit monitor, view CloudWatch logs. So then we send it over here. We got CloudWatch logs, and this is what API Gateway is sending. As you can see, the root key is a post with the path of pet, and the data, pet ID, pet name, pets, and stat is hashed in this body right here. So let's go through the code and see what's going on. So we have our handler.js. This is the Lambda function that we're running. And when the event route key equals post pet, we're going to head into here. So this is what we're doing. We're creating a new pet with post. So what you're going to do, it's going to grab that body. That's this string right here. This string right here. We're gonna grab that body and we're gonna break it up because it's encoded with base64. So we have to break it up, decode it, and then grab the search parameters from this. So we got pet ID, pet name, and the stat. So then we have to use this JavaScript library called Joy to validate our inputs. So as you'll see, pet ID, it must be a number and it must be required. Pet name is alphanumeric and required, and so forth. So if you send something, let's say you don't include the pet name, it's going to kick back to you that say pet name must be a string. So that's what we're doing, Joy, to validate everything. And then it sends it to this function pet name. And as you can see, the DynamoDB client is sending it along with you. That's to make the Lambda function extra efficient. We want to instantiate the DynamoDB client at the start. So if you send multiple requests very quickly, it can reuse the same Lambda function that's already firing up. It doesn't have to make a new connection every time a request is sent. So let's go through this and see what's going on. Add pet. So we'll head to the add pet function. And as you see, we're passing the DynamoDB client and the pet data. So we are connecting to the pet table dev, which is a DynamoDB table. And we are saying, okay, we're looking for a number, pet ID, a string for status, and a string for a pet name. And we have a condition expression that says the attribute not exist. So if the attribute exists already, we're going to fail. So when we take these params and send it with the put item command to DynamoDB, if it doesn't exist, it's fine, it just goes through. If it already exists, it's going to throw this error, and then we're going to catch it and say not creating pet already exists, and then we're going to return that message. But if it doesn't exist, we're going to go through there and see and do a secondary check. So for some reason, if the item already exists and this doesn't work, this condition expression doesn't work, we're going to see if the data has any attributes already, and if it does, it's going to say, hey, item already exists, but it's still going to overwrite that data because this did not, the DynamoDB request did not throw an error. But that shouldn't happen. That's just there for a backup. So if it does work and if the attributes don't exist, we're going to simply create the items and then return the message that the pet is created. And let's just go back to this guy, and if we send that same thing again, just to make sure, not creating is because pet already exists. And you can see, those requests have been sent to the Lambda function in CloudWatch logs. So let's go through the next functionality, and we're going to, so we've added a new pet to the store, and let's just grab that pet. We have the get function, same API gateway link, and just we're grabbing the pet 3241 that we've already created, and this is simple right here. So this is the pet ID, we've named Tony, and it's available. Okay, next up we want to add a image upload to this pet. So how that works is we are going to post an image and we are going to send a file name. So let's just do that right now. And we got image was added to the pet profile. So as you can see, these are the URLs that the pet contains, and this is the upload data. So what it's doing is it's grabbing that file name, sending it to the Lambda function. The Lambda function is creating a pre-signed URL for S3, sending that data back. So then you could use your front end, like a React app or something, to directly upload to S3. This way you don't have to send data through API Gateway, and it's just way more efficient, especially if you're using larger file sizes. So you would take these fields, put it all into a payload, and then send it to this link along with your image data, and then that would be directly uploaded to S3. So let's go through the code a little bit and see what's going on. Okay, so we got the upload image. So as you can see, we have the handler. The first one was creating a pet, the second one was getting a pet, and then we have to upload the image right here. So let's go to functions, upload image, add image right here. And so what we're gonna do is this actually requires 2 DynamoDB calls. The first call is just to make sure the item already exists, because we don't want to be adding an image. It'll actually create a new pet automatically if it doesn't exist, so we want to stop that. We don't want any pets to be created without pet IDs or anything like that. So we check if it exists. If it doesn't exist, so the pet doesn't exist, we can't add an image to it. So this will just return pet doesn't exist, image not added, and just nix the whole thing. But if it exists, we'll grab that data and then we'll move on. So we have to create the S3 key from the pet ID and the file name. This way that under this bucket, every pet ID will be a prefix, and then under that prefix, it'll have all the URLs, all the files for that particular pet. And what we're doing here is we're creating a pre-signed post. This is a S3, so we're creating an S3 client here from the S3 library, AWS S3 library, and we're using this client to create a pre-signed post URL, and this should give you the URL and the fields, as we saw right here, the URL and the fields, which we can upload with a payload, which will help us upload to S3 directly. Then we check the DynamoDB table. We grab this pet ID from this table, and we have to add it because we want to do a set of strings. That's what SS is in DynamoDB. It's a string set, so it's a set of strings, and we need to add our photo URL to the string set. So that's what we're doing. We're grabbing the keys from the fields. So fields, as you can see right in here, we have the key. This is the user, the pet ID with the file name, and adding this key to the DynamoDB table, so it's really easy to grab from S3. So how does this work? So we have the update item command because we're updating the pet ID in DynamoDB table, and then we are creating this new file name, which is again the S3 key. We're creating a message that we're adding to the response dictionary, and so then we have to go and make sure that if the photos exist, this means there is already photos, we're going to do this. But if there's no photos currently under the pet, we have to create a new file name, kind of a new array. This turns into a set once it actually gets to DynamoDB table, but we want to create a new array, push the new file name, and then return that array so you can actually see that the file was added. But if it already exists, and it already has one photo, we need to check to see if the image exists within that set, and if it does, it's just going to overwrite that image. So it's not actually overwriting it, but it's sending a link to you, so when you upload that link, it will overwrite with it will overwrite the S3 bucket with that new link. And if it doesn't exist, we need to grab the current set from DynamoDB table, add the new key, and then send that whole thing back as the response, so it has it included. Okay, that's how the add image works. Let's keep moving. So we have next one. We can simply update the pet, and let's say we want to change the name from Tony and available to Peter and sold. So then we're gonna send this post. Pet is updated, and then if we go back to the get command, we can see it is now Peter and sold, and it also has that photo URL that we have uploaded. Okay, and just to go through The next functionality in this one, so we've added the pet, we've uploaded the image, we've found the pet, we've updated the pet. So now we have to use this find by status. So let's go through this one and do this one. So we're find by status is available. So we got this guy, and I've added a few other pets already, but this returns every pet that is available. So if we wanted to do sold, I think there would be a lot less, and we would have that one that we just updated. So yeah, we have that. We have the item that we have just added. We've updated Peter, and it's sold now. So that's how we find it there. Okay, let's go through the code for how this is working. So again, we have the find by status in the handler. So we want to upload the image. We want to find by status. It grabs the query string. So right here, the find by status is a query string in the link. So it grabs that, splits it up, because if you send, you can also do this and create and stat equals available. So you can also create multiple, you can search for multiple statuses. So this one's available, and then we go down to is also available, but this one's sold. So it includes all of them, and you can add the third one there as well. So that's why we had to go and we had to split it by comma. So we had to grab the query strings and then split the comma, and that turns it into an array. We have to make sure that it is an array, whether it's 1 or 2 or 3 items, and then we have to go and validate that. So we use this joy JavaScript object to validate the input, making sure it's array, and then we send it to the find by status function right here. So what we're doing is we have to stitch together a filter expression. So I don't know if they're sending 1 status available or 2 statuses or 3 statuses. So we have to iterate through the statuses, and then we have to add them to a filter expression. And that's what we're doing right here. So we basically just have to, however many statuses there are, it adds to the filter expression, and then that gets inputted right here. And then we have the expression attributes, again, to say which one. So we're going like, is it the first one we're looking at, or is it the second one? I'm not going to go through the details, but this is how we do it. And then we're going to return all this data for all those statuses. And we're going to use the scan command. So that actually scans all the items in the DynamoDB table, which can be inefficient, but right now we have a short, small set, so it actually doesn't consume any more read capacity units than a normal request. So this is actually efficient here. So that's how we do that. We build the expression, and then we send it out. Okay, let's keep moving. And then if we want to do the final functionality is the delete. So we have this one, and then we go pet deleted. If we go back to here, we talk that same pet, boom, pet doesn't exist. Okay, so that is the pet. We've added it, we've uploaded it, we've checked by status, and we've done all 6 of the API calls for the pet. Now we're gonna move on to the store. So if we have a store right here, and I have to make sure this doesn't exist. Okay, so that does exist, and then whenever you send a new order, it will overwrite it. But let's just go and let's just delete this real quick to make sure. So 4321. So again, not found. Because we're doing the wrong link right here. So this should work. Order deleted. Then we can go back here, and then we can go and re-add this order. So we have the order is created with this pet ID, this quantity, and this status. We can grab that order right here, and it sends it to us. So let's go through this real quick and see what's going on. So we have deleted it. So we got our store order. Same process before. We have to grab the data from the body after we decode it. We have to use joy to validate the inputs, and then we send it to the store order. We have a different table with these attributes in it. As you can see, I've added the ship date and the complete, so those would be updated in the backend, but we don't need to add them in the original request. And this works the same way as the pet. Overwrites the order if it already exists, because this one doesn't check, because again, it's an order, so that's what you have to do. If you want to update it, you just rewrite a new order. Okay, let's keep going. We have the orders, we've gotten the orders, and then now we can delete the orders, and now we can check the order by inventory. So this one, order inventory, what it does is it sees how many orders have been placed, and then gives you the amount of approved orders, delivered orders, and placed orders. So let's go through and just make sure this works by, let's add a new order, and let's call this approved. So when we send this, a new order is created, and then we can get the inventory, and approved should be 0. Now it should be 1. Okay, so let's go through this quickly and see what we're doing here. So in the handler, we're going to grab the inventory. So it sends it to the store inventory function. So right here, we have, there's no actually request sense, it's just grabbing the inventory. And this is doing another scan command. So if the order database gets pretty big, this can be quite inefficient for DynamoDB. But since it's a small table, it's just as efficient as calling one item at the moment. So what we're doing is we have this object that just counts the approved, delivered, and placed. So it goes through, iterates through every single item saying, hey, what's the status of this thing? If it's approved, it adds it to it ++, it adds 1. If it's delivered, it adds 1, and placed, add 1, and then it returns the whole thing. Okay, that is great. That is the functionality of the Pet Store API written on NodeJS. Let's talk a little bit about the testing. So we have these tests that have been created to basically just run through all the things that I just did really simple. So we're going to use the JavaScript library called Jest, and let's just do, so I've added it to the thing. As you can see in the package JSON, we are using Jest, and when we test it, it's just going to use Jest. So we're going to go npm test, and this is going to go into the test. It's going to test the pet and test the stores. So what's going through here is that this creates a pet. So we make a random pet ID, and we send it to this add pet. It should add it. Then we should add an image to the pet, just a random image. And then we should get the data about the pet, get this data, and then it should delete the pet. So as you see, it creates this order with this random, let's do it the wrong way. Let's do the pet first. So we're trying to add this random pet. So we add it. We're trying to add an image. It works, right? We fetched it. It has that image that we've added. And then we delete it, and we have deleted it. Yep, and then we can go to the store, and this one, it adds a new order and then deletes a new order. So it creates a new order with that random order ID, and then it deletes that same order. So this is pretty cool because you could just run the tests to make sure you have everything working, and you can make it automated. So if you add a change, or you're working with multiple people, someone can change it, and then they can run this simple test, and it will go through that. Another cool thing is that this thing is created with serverless. So we're going to go through, and we have this serverless. So we have this HTTP API, and we have this serverless app. This makes it quite easy to upload. Let's look at the serverless YAML. So what we've done here is we've created a YAML file with serverless. We've created a pet name on DynamoDB, a store table, and then an image bucket on S3. So we have this provider that we have, which allows basically most of the DynamoDB function and then all of the S3 function in the region of US West 2. And you could, if you wanted to upload this to production, you could change the stage and re-upload it very easily. And then we have our pets API function. These are the API paths that it will send to. And we have this resource, which is the pet table, which was the name was up there. We have the store table, again, the attribute name and the key schema. And then we have the images bucket. So this will launch all of the things with CloudFormation, but serverless makes it really easy to update. And one of the cool things, so if I wanted to do serverless deploy, that would re-upload all the S3 bucket, the DynamoDB table, and it'll create a change set and make sure it all is working. But if I just want to update the function, I can do this one, serverless deploy function, and the name of my function, and it actually only takes about 15 seconds. And so if I make a change in the Lambda code, it actually uploads very quickly. Whereas the full deploy would take a minute or two, this one can update very quickly and make that function great. And then we can check it on the serverless website. We can check our function. We know how many times it's been called. We know how much memory we've used, and we can follow along with what's going on. So serverless makes things quite easy, quite useful. And if you want, you can launch this same function on your own. You can see this. You can see this project. I have it on my GitHub. You can download this, clone it to your repository, and then launch it with serverless. And yeah, the whole thing should just upload really quick and work quite well. So that's how you create an API with Node.js and Lambda. Here is my example. I hope you have enjoyed it. Thank you so much for listening, and I'll talk to you next time.